example, okay? So a real example where we do classification using the naive Bayes algorithm or the naive Bayes formula. So let's consider a classification problem like, we want to classify surfaces based on the vibration created by them. So vibration we measure using the acceleration and the gyroscope. It's like your step counter, okay? They measure your acceleration and your gyroscope. And acceleration can be measured in 3 different dimensions using a triaxial accelerometer, which is in your smartphone. So like acceleration x-axis, y-axis, z-axis, similarly gyroscope, x-axis, y-axis, z-axis. Based on that, 6 features, you can classify the vibration into a particular category, and we can label it saying that, okay, this is carpet, this is concrete sidewalk, this is asphalt, something like that, okay? So there's a list of features. X equal to is a x1, x2. There are 6 features. There can be n number of features. There can be many other problems like, let's say, spam detection. If a email is a spam or not, you detect based on whether the presence of certain keywords. Let's say advertisement or buy or a sale, something like that. So you can detect whether this keywords appearing determines that is a particular case of a spam or not. Okay, it doesn't mean that mail will be spam if the words appear, but it can be checked. Okay, so the Y is the class, the final decision, what we are trying to say. For our case, this example I picked because this is a multi-class classification, right? So there can be many different surfaces in the world, and they can be classified based on the surface types, the vibrations created by them. So, but for the spam classification, this can be it's a binary classification, yes or no. Okay, Y will have 2 values. So I have chosen this because it's a multi-class classification. So now you see the generic formula of Bayes rule is that Y given X, given these features or given the values of this feature, is probability of those features given Y and multiplied by probability of Y divided by probability of X, that means the features. So now you see we expand this using the chain rule, that one, because now we have X is a set which have a lot of different features. So we say probability of Y, that is the outcome of the class level, is given all those different individual features. I have like 6 features here, but there can be n number of features, so we can generalize it to xn. Now we say probability of x1. So this one we expand saying probability of x1 given y times probability of x2 given y until probability of, let's say, xn given y. But here we have 6 features, so we say x6 given y, okay, times probability of y, and then the denominator will always stay same for all different surface classification. Like if there are multiple y, we can have different formula. So this you see in the following one, because this one, the probability of individual features is kind of repeating or occurring again and again. All the formula is the same. So we say that it does not depend, the left side does not depend on the denominator, but rather on the numerator. So the left side is proportional to the numerator, okay? Probability of y times this pi I equal to 1 to n, probability of xi y. So this part we generalize, okay? Pi means multiplication, like sigma means sigma equal to 1 to n, I means, i's value changes from I equal to 1 to n, and you sum those terms. But pi means you multiply those terms, because they are all in multiplication. You use pi I equal to 1 to n, probability of xi times y, so it will change x1, x2, x3 in that way. And now we say y equal to argmax y, probability of y times this. So argmax means you find the maximum probability outcome from here, okay? So this posterior probability, whichever class gets the maximum probability, that will be the final class, okay? So if you have let's say you have 2 cases, right? If it's a binary classification, yes and no 2 cases, you evaluate the posterior probability of both of them using the Bayes formula with respect to the given feature set X, and you find that the yes, for the case of yes, the probability is higher, let's say 0.7, and for the case of no, the probability is 0.3. So we'll say, okay, yes will be the answer. For our case, which is the multi-class classification, we'll have surface, probability of surface 1, probability of surface 2, until probability of surface n. If there are n number of surfaces we have data collected from. Now you see, we do the posterior probability calculation, we find that, let's say, probability of surface X or K is the maximum. So we'll say, okay, based on that feature, the surface should be classified as probability or the surface type K. Okay, so there are 4 steps to follow to come from this formula to the final determination of the which class level it should have. First, we create a frequency table for each feature given from the given data. Okay, so like this frequency table for each feature. For x1, there will be a table. x1 has different values, and what are the outcome value of y for that. Okay, we'll also that is called a frequency table. From frequency table, we'll create a likelihood table by finding the probabilities. Actually, in the previous example, I have already shown how to create a likelihood table where individual probabilities are calculated. And using that likelihood table, now we will use the Naive-Bayes equation to calculate the posterior probabilities for each class. Okay, so using this formula, and whichever class will have the highest posterior probability, that will be the outcome of the prediction. And we will see another example for that. We have kind of changed what we want to determine a little bit. We are now saying that, okay, what is the probability that an email is valid or spam, depending on the occurrence of 2 words, gift and discount in them. Okay, gift and discount. So this W now does not represent all the 4 words, but 2 words. So what we did, probability of gift, given it's valid, and probability of discount given it's valid, times the probability of the email itself is valid. We have multiplied all of them and find the probability is 0.07305, and also the probability of this email being spam given this 2 words, gift and discount, is also given its gift. We know that it's gift given its spam, and so this appearance of the word discount given its spam times the probability of it being spam. So we multiply it, find 0.11, which is definitely a bigger number than this one. So we know that this will be a spam. But now, what is the percentage of being spam? So we calculated this percentage of probability of being spam divided by probability of being valid plus probability of being spam times 100, and we get a 61.54% chance that this email will be a spam email.